Hi guys! Okay, so we're ready to do another objective in the logarithmic functions section. And these problems start with the directions. Given the approximations, log base 2 of 10 equals 0.3010 and log base 10 of 3 equals 0.4771, find each logarithm without using a calculator. So what we're going to do here is we're going to apply properties of logarithms in combination with these two given approximations in order to figure this out. So the first question is log base 10 of 6. So we're going to evaluate log base 10 of 6 but without using a calculator. So just to remind you, like normally if we're going to evaluate something like this, we would possibly use the change of base formula where we do like log base 10 of 6 over log base 10 of 10. But that's cyclical because I might need to remind you that if you don't have a base shown with a log, it means that the base is 10. So if I try to use the change of base formula, I kind of go in circles here because remember, if you have one of the properties we learned in the previous video is let me show you these properties here, where if you have a log of a base of itself, it equals 1. And that's because no matter what your base is, if you rewrite this in exponential form, what you get is a to the power of 1 equals a, right? Which is true no matter what your base is. It could be 3, it could be 3 to the power of 1 is going to be 3, 2 to the power of 1 is going to be 3, and so on. So because of that, if I tried to use my change of base formula to evaluate this, it will just send me around in circles, because then I'll come back to log 6 over 1, which is just log of 6, which is the same thing as log base 10 of 6. So anyways, we're not going to use the change of base formula here. We're going to use the approximations. We could go right into Excel and just go log 6 equals whatever, and then we'd have the answer. But the whole point is to apply our properties. So I've got log base, I need to rewrite this. It's actually log base 10 of 2. So I've got log base 10 of 2 equals 0.3010, and log base 10 of 3 equals 0.4771. So they're both base 10. Technically, we don't even need the 10 to be there. Alright, so now I've got log base 10 of 6, and again, that doesn't even need to be there. But I have log base 10 of 6, and then up here I have log of 2, log of 3, and I know that 6 is the product of 2 times 3. So I could actually use the product property to expand this to 2 separate logarithms, both of base 10, and then use those approximations I was given. So this one gets replaced with 0.3010, and this one gets replaced with 0.4771. And then I just do the simple addition there. Remember, when you add decimals, you want to line up their decimals. So 0.3010 and 0.4771 is 1877. Okay, so the answer is log base 10 of 6 is 0.7781. And you could actually, go right into Excel and just discover whether or not that's right. But that's the answer right there. Okay, so let's do another one. Let's do log base 10. Again, we don't need the 10 there, but I'll put it anyways. Over of 20 over 27. And what were my two things again? I had log of 2 and log of 3. So can I do anything with log of 2 and log of 3? Well, let's first just try expanding to log 20 minus log 27, so that I'm using the quotient rule here because I've got a quotient, so I can rewrite that as the difference of two logarithms. They're both base 10. And then, let's see, 2 is a factor of 20, so I could rewrite this as log base 10 of 2 times 10. And this other one, log base 10 of 3 times 9. And then I can expand this to be log base 10 of 10. So I'm just going to use the first factor plus log base 10 of 2. So that's this part. Then minus log base 10 of 3 plus log base 10 of 9. And then simplify what I can. So this is 1. Then I have log of 2, which that was one of my approximations. Log of 2 is 0.3010. So I'm going to put that here, 0.3010. Then I have minus log base 10 of 3 and minus, because I'm distributing this negative here, minus log 10 of 9. So I have 1 plus, well, I can add 1 in that other number, that's 1.3010, minus, what's this? That's another approximation we were given up here, 0.4771. So I'll put that down, 0.4771. And what is log base 10 of 9? I think we're going to have to expand this again. So let's make this 3 times 3, or 3 squared. How about 3 squared? Yeah. How about we'll make this log base 10 of 3 squared, and then that 2 can come in front using our exponent property. And then this is the 0.4771 again. So now I've got 1.3010 minus the 0.4771, and then minus 2 times 0.4771. Wow. All right, so now we just have to do the math here. This is negative times this, and this is negative 2 times this. So negative 1 and so that's actually 1.3010 minus 3 times 0.4771. So I'm going to do some side work over here, and I'm going to work out what is 0.4771 times 3. 21, carry the 2, and then 4 decimal places. So I'm going to do 1.3010 minus 1.4313, which means I'm going to have a negative result. And then, so if I do 0.14313 minus 1.3010, then I get negative 0.1303. Phew! That was, what are you guys thinking that was? Yeah, me too. I was thinking that was really fun. I think it's awesome. So I hope you enjoyed that. I'm going to stop there. If you want more examples, there are plenty in the back of the section in the textbook, and a whole bunch that I've assigned in the unit quiz and the, yeah. So you have plenty to practice. Enjoy.